Good morning. In this video, we will be discussing about how to diagnose various acid-base disorders. Before going into that, we will have a quick glance about the various acid-base disorders. The normal pH balance is maintained mainly by lungs and kidney. If the regulation by the lungs fails, it leads to respiratory disorders. Whereas if the renal regulation fails, it leads to metabolic disorders. The primary function of lung is to eliminate carbonic acid in the form of carbon dioxide. If this is not done, carbon dioxide, that means carbonic acid, will accumulate and it leads to respiratory acidosis. On the other hand, hyperventilation will lead to excess removal of carbon dioxide or carbonic acid, leading to respiratory alkalosis. Coming to the metabolic part, the main function of kidney is to remove the organic acids formed in our body and to increase the bicarbonate level in the body. If this fails, what will happen? Acids will accumulate and the base level will decrease, leading to metabolic acidosis, whereas the reverse leads to metabolic alkalosis. To sum up, if the acidosis happens due to decreased bicarbonate level, then it is called as metabolic acidosis. If the same acidosis happens due to increased carbon dioxide, that means increased PCO2, then it is called as respiratory acidosis. If an alkalosis happens because of increased bicarbonate, then it is called as metabolic alkalosis. On the other hand, if the same alkalosis happens because of decreased PCO2, then it is called as respiratory alkalosis. So these four things you should never forget. Okay, so decreased bicarbonate leads to metabolic acidosis. Increased PCO2 leads to respiratory acidosis, increased bicarbonate leads to metabolic alkalosis, and decreased PCO2 leads to respiratory alkalosis. Okay, so now we will see how to diagnose the various acid-base disorders. For this diagnosis, we mainly need three parameters, which are nothing but pH, PCO2, and bicarbonate level. Among these, pH and PCO2 will be estimated in the arterial blood with the help of an instrument called as blood gas analyzer. So this blood gas analyzer will give you the pH and PCO2 value. If you substitute this pH and PCO2 value in Henderson-Hasselbalch equation, you can easily get the bicarbonate value. Okay, so this is how we can get all these three values: pH, PCO2 and bicarbonate. Okay, so in this pH and PCO2 is directly measured by the blood gas analyzer, whereas bicarbonate is calculated by substituting the other two values in Henderson-Hasselbalch equation. Okay, so now with these values, how to diagnose it? Okay, before going into that, first you should know what is the normal value for these three parameters. First, the normal blood pH, arterial pH, is between 7.38 to 7.4. Okay, actually our mean value is 7.4. Okay, so plus or minus 0.2 we are keeping. So 7.38 to 7.42 is the normal blood pH. Next, normal PCO2 is between 35 to 45 millimeter mercury, whereas normal bicarbonate level is between 22 to 26 millimoles per liter or milliequivalents per liter. So this is the normal value. So now we will see how to interpret the various ABG reports with the help of these parameters. Okay, so let me take two examples and I will demonstrate you how to diagnose various acid-base disorders. Now the first scenario, let us assume that a patient X, this is the report of a patient X, whose pH is 7.2, PCO2 is 23 millimeter mercury and bicarbonate is 10 milliequivalents per liter. Now with this value, we will find out how to diagnose the acid-base disorder. So now in this, first you should see the blood pH. Okay, so that is the step one, you should be doing it. Just see the pH and identify whether it is acidosis or alkalosis. Okay, so what is the normal pH? I said it is 7.4. Okay, anything less than that we call it as acidosis. Anything more than that we call it as alkalosis. Okay, suppose if it is exactly at 7.4, then we can say it as normal. Okay, but before saying normal, you should see the other values also. Okay, so if pH is between, if it is exactly 7.4, you should see PCO2 and bicarbonate values also. If all three are normal, then you can name it as normal. Okay, otherwise if it is less than 7.4, then it is acidosis. If it is more than 7.4, it is alkalosis. Okay. Next, with this you fix the first diagnosis. Okay. Now coming to our case, just see the pH, what it is, whether it's acidosis or alkalosis. pH is 7.2, it is less than 7.4, so it is a case of acidosis. Okay, so in step 1, just see the pH and fix the diagnosis as acidosis or alkalosis. Next, step 2, here you should see the PCO2 and bicarbonate value and you should find out which is favoring your step 1 diagnosis. Okay, in acidosis, what is acidosis? Acidosis, two types are there. One is metabolic acidosis and respiratory acidosis. Okay, so metabolic acidosis means bicarbonate level will be decreased and respiratory acidosis means PCO2 will be increased. So here what is the PCO2 level? It is 23 millimeter mercury. Okay, so which means it is decreased. The normal PCO2 level is 35 to 45 millimeter mercury. Here it is just 23. It means decreased. Okay, so decreased PCO2, will it cause acidosis? No, it will not cause acidosis, it will cause alkalosis. Okay, so in this condition, the acidosis is not due to the respiratory problem. Okay, next coming to the bicarbonate, what is the normal bicarbonate level? It is between 22 to 26 millimoles per liter. Okay, but here it is just 10, which means bicarbonate has decreased. So decreased bicarbonate will lead to acidosis. Okay, so here you have to see PCO2 and bicarbonate. Okay, if PCO2 is favoring your step 1 diagnosis, then it is a respiratory disorder. If bicarbonate is favoring your first step 1 diagnosis, then it is a metabolic disorder. If both are favoring, then it is a mixed disorder. Okay, so here in this case, bicarbonate is favoring. Okay, bicarbonate is low and it can lead to acidosis. So this is a case of metabolic acidosis. Now see the other component. Okay, now bicarbonate is favoring. Okay, so we have made the diagnosis as metabolic acidosis. Now see the other component, okay, which is not favoring your diagnosis, PCO2. So here PCO2 is decreased. Okay, so why it is decreased? It can be either due to two reasons. One is as a result of compensation, it might have decreased, or there may be a combined respiratory disorder also. Okay, so how we can differentiate between these, whether it is due to compensation or it is a combined disorder, how we can differentiate means, for that we have set of compensation formulas. Okay, so in each condition, how the other component will change. Okay, so how it will change, how much it can compensate, for that we have a certain formulas. Okay, so here out of this formula, now in our case is a metabolic acidosis, so we have to take this first formula. Okay, so in this formula you have to substitute the bicarbonate value. So what is the bicarbonate value in this patient? 10 milliequivalents per liter. So when you substitute this 10 in the formula, the answer comes as 23. Okay, so that should be the compensatory PCO2 level. But what is the patient's level? That is also same 23 millimeter mercury. Okay, which means this change in PCO2 is most probably due to compensation. Okay, so which means the diagnosis is metabolic acidosis with compensatory respiratory alkalosis, with compensated respiratory alkalosis. Okay, that is the diagnosis. Sometimes if the PCO2 is still reduced, okay, it is beyond 23. Okay, if it is beyond the level of compensation, then it is not due to compensation. There is an added or another mixed disorder. Respiratory alkalosis is also a pathology in that patient. Okay, so that is how we can differentiate between compensation and the combined disorder. Okay, so these are the three steps involved with the diagnosis of any ABG disorders. Okay, with this you can almost 90 to 95% of the cases you can easily interpret. Okay, so first step is just see the pH. Okay, by seeing the pH, make the diagnosis as either acidosis or alkalosis. If the pH is below 7.4, make it as acidosis. If it is above 7.4, make it as alkalosis. Okay, after this, next step 2 is see the PCO2 and bicarbonate level, which is favoring your step 1 diagnosis. Okay, if PCO2 is favoring, then it is a respiratory disorder. If bicarbonate is favoring, then it is a metabolic disorder. Okay, so after confirming the diagnosis, now you have to see whether it has compensated or not. Okay, for that you have to find out for this particular disorder what is the formula, substitute the value in that formula, you will be getting that formula, compare it with the patient's value, and you can easily make out whether it is compensated or not. Okay, so this is how acid-base disorders can be diagnosed. Now we'll see one more example so that we can get more clarity. Okay, so here this is the patient, another patient for whom the pH is 7.39, PCO2 is 24 millimeter mercury, and bicarbonate is 14 milliequivalents per liter. Okay, so first we'll start. What is the first step? see the pH. Okay, so here pH is 7.39, which is less than 7.4. So make the diagnosis as acidosis. So step 1 diagnosis is acidosis. Okay, fix this. Next, see the PCO2 and bicarbonate level, which is favoring acidosis. Okay, PCO2 here it is 24 millimeter. It is decreased. Okay, decreased PCO2 will never cause acidosis. So it is again not a respiratory disorder. Coming to the bicarbonate, that is decreased. Base, if it decreases, it can lead to acidosis. So bicarbonate is favoring. Since bicarbonate is favoring, this is a metabolic disorder. Okay, so after confirming the metabolic acidosis, you take the formula and substitute the bicarbonate value to find out the PCO2. Okay, so this is the formula. So here if you substitute the bicarbonate level, the PCO2 level comes as 29 millimeter mercury. Okay, suppose if the lungs has compensated, it can go up to only 29 millimeter mercury. But here it has further decreased to 24 mercury, which means this decrease in PCO2 is not due to compensation. That means there is an additional disorder. Okay, so this patient is suffering from both metabolic acidosis as well as respiratory alkalosis. Okay, so the best example for such a condition is salicylate poisoning. So salicylate poisoning, what will happen means the excess salicylic acid you are consuming, they directly can stimulate the respiratory center and it can lead to respiratory alkalosis. Okay, but in addition to that, the sum of the salicylic acid which gets metabolized in our body, they can produce oxalic acid and it can lead to metabolic acidosis. Okay, so this type of mixed disorder can be seen in salicylic acid poisoning. So there you'll be getting a similar type of ABG report only. Okay, so that's it about diagnosis of various acid based disorders. Okay, so if step 3 is confusing, you can skip that. At least step 1 and step 2 is very important. Okay, just see the pH, fix the diagnosis. Okay, after that see the PCO2 and bicarbonate and fix whether it is respiratory or metabolic problem. Okay, thank you.